right, today we're going to learn about a family of special right triangles that really comes down to two that you can kind of carry around with you. And as a memorized trick, you can apply them with proportions and similar triangles to a vast amount of problems. So it really starts with, let's look at this one special right triangle we got in front of us. So this one right here is an isosceles triangle. So what do we know about isosceles triangles? Well, we know if two sides are equal, well then the two base angles are equal. And in this case, since they add up to 90 in this triangle, we know that these two equal angles or congruent angles must be 45 degrees. Okay, so if these are both 45 degrees in every single isosceles right triangle, we know that by angle-angle similarity, every other isosceles right triangle is going to be similar to this one. So if we come up with any set of sides for this, whatever numbers fit, then it's going to be proportional to every single other 45, 45, 90, every single other isosceles right triangle out there. So let's just come up with the easiest number I could think of here. Let's say this side is 1. Okay, well, the side on the left is also congruent, so this side is 1. And that missing side we could figure out here with the Pythagorean theorem. So if we got two sides of 1 in this triangle, we could say, okay, well, a squared plus b squared equals c squared. It's 1 squared plus 1 squared is c squared, so 1 plus 1, that's 2. So c is square root of 2. So every single isosceles right triangle is going to be similar to this one because it's also going to have 45 degrees, and 90. And it'll just be some multiple of this. And we'll come back to this in a minute, okay? So we have one other special triangle here. Now this one isn't even a right triangle yet, but in an equilateral triangle, we know that all the angles must be congruent. And if all the angles are congruent, that means they're all 60 degrees, okay? And if we just ignore this bottom side for a second, I see the isosceles triangle. I know that I could cut that right down the middle with a perpendicular bisector at the bottom, but just cut that right down the middle and split this equilateral triangle into two symmetrical halves. So I'm going to do that. I'm going to take a different color here, and I'm going to slice it right down the middle. Okay. Now I know that means this is perpendicular. It bisects that angle at the top. So we have 30 degrees. So I'm going to write that down here. We've got a new triangle here that's formed just being half of an equilateral triangle. This triangle is 30, 60, 90. Okay, so half of an equilateral triangle. Well, let's again come up with the easiest possible number I could think of here. Let's say this bottom segment here is 1. Okay, well this bottom is split into two congruent parts. So this is 1. Which means this side is 2 and this side is 2. So in our triangle, our 30, 60, 90, if we set this bottom side equal to 1, we know the hypotenuse here is 2. And again, we could find that missing side. We could say, okay, well, 1 squared plus something squared equals 2 squared. So that's 1 plus b squared is 4. So b squared is 3 and b is root 3. So we could find that missing side. So this special triangle is just half of an equilateral triangle. And again, anytime you forget, you could kind of just refer back to here. And yeah, so let's see how we can use this. Okay, so let's scroll down here. So that's what we kind of figure out about these two triangles now. Okay, so every single triangle with angles 45, 45, 90, or in other words, every single isosceles right triangle is similar to this triangle here. So this triangle is 1, 1, root 2. Over here on the right, this is an image from our book. This shows that every single triangle of 45, 45, 90 is a multiple of 1, 1, root 2. So if I multiply each of these by x, I get 1 times x, 1 times x, and root 2 times x. Okay. Or 30, 60, 90, every single triangle with angles 30, 60, and 90 is similar to this triangle. So 30, 60, 90. Now I don't, off the top of my head, I don't remember which side goes with which. So the little trick I use to remember this is that I know that the largest side is opposite the largest angle. And I know that the medium goes with the medium. I know that the small goes with the small. And so if I just look at my numbers, I have 1. I have root 3, which is around 1.7. And I have 2. So I've got a small number, a medium, and a large. So I know that across from my smallest angle over here is my smallest side. Across from my medium angle is my medium side. And across from my biggest angle is the biggest side. I'd say the single biggest mistake I see when people are working with similar right triangles or these special right triangles is people mess up which number goes in which location. So it's really important that you get the 1 or smallest side is across from the 30 or smallest angle, and so on. Okay, so let's actually apply this now. We've got these 2 triangles here. Let's use them, okay? And I'll make this one note first. This is back from algebra. Remember, always rationalize the denominator. Whoops, spelled that wrong, but here we go. So if we have a square root in the bottom of a fraction, this doesn't change the value of your answer, but it simplifies it. And the reason why is to combine like terms, and we could talk about that another time. But to rationalize this, to get rid of the square root, we know if we multiply any square root by itself, that's squaring a square root, that cancels out, and on the bottom of this fraction we will have 7 now. But of course, whatever I do at the bottom of the fraction, I got to do that same multiplication on the top, so really I'm multiplying by 1. And so I get on the top 14 root 7. And now 14 can be divided by 7, so this is 2 root 7, which is the simplified version of this first fraction. Same value if you plug it into a calculator, but that's the simplified version. Okay, so let's apply these 2 triangles down below, okay? So here's some problems from our book. We've got this triangle here to start, number 3. Okay, what I'm going to do is I'm going to notice that there's this 45-degree angle here, a 90-degree angle, so this missing one must be also 45 degrees. We could just subtract from 180 to find that, or from AA, right angle 45. We know it's similar to this one right here. So what I'm going to do is I'm going to take this one that we've got right here, okay, and I'm just going to bring it down here, and I'm going to put that same triangle here, and I'm just going to rotate it. Now I think, whoa, look at that. Okay, so I'm just going to rotate it so we've got it like this, okay? Now that's hard to read, so what I'll do is I will just actually end up deleting that. Let's redraw it, okay? So I'm going to take that 45, 45, 90 triangle, and I know that these 2 sides of my isosceles triangle are congruent. They're my 1 and my 1, and the hypotenuse is my root 2. And now I can use a proportion to solve this. An easier method, when it works out easily, is to notice that between these 2, there's a scale factor of 7 to 1. That doesn't always work out nicely with the square roots, but if you notice that, you could say, oh, this larger triangle with the 7 and the x is 7 times longer by side, so this x is 7 times root 2, okay? And that could save you some time. Otherwise, you can always go to proportions. So you could always say these triangles are similar, so x is to root 2 as 7 is to 1. Cross multiplying, you get 1x equals 7 root 2, or x equals 7 root 2. Okay, let's do another one slightly harder here. Let's look at number 4 now. So number 4, we will set this up. Notice that these 2 sides are equal, which means these angles are equal, which means we've got our 45, 45, 90 triangle. Notice now I'm orienting it exactly the same as my image, and I'm going to put my 1 and 1 here, and my root 2 here. And now I'm going to use proportions to solve this. I'm going to say, okay, so x is to my root 2, going from this triangle to here, as, and then a different set of sides. So let's say as 5 root 2 is to 1. Okay, so cross multiplying here, I've got 1x, or just x, is equal to 5 root 2 times root 2. But I know that root 2 times root 2 is 2, or root 2 squared, so that's x equals 5 times 2, or x equals 10. Okay, so now let's try it with the 60, 30, 90 triangle here. Okay, so again, I see my, let's go to blue here. I see my 30 degrees, I see my 90, so the missing side must be 60. So I will draw my similar 30, 60, 90. Again, it's important which side lengths go where. So across from 30 is my smallest. Across from 60 is my medium. Across from 90 is my largest. And now I can set up any proportion to solve here. We're doing number 8. So I'm going to do two separate things. I'm going to solve for x first and then y. So over here, I'm going to say x is to root 3, going from the top triangle to the bottom, as 9 is to 1. So cross multiplying, I get 1x equals 9 root 3, or x equals 9 root 3. Okay. Now let's try and solve for y. So we get y is to 2 as 9 is to 1. So we get 1 times y, which is just y, equals 18. Okay, so let's look at another problem. Now this one's already set up for us. Describe and correct the error in finding the length of the hypotenuse here. Okay, so they're saying that they used the 7 here to find the hypotenuse. What is wrong with that? Okay, so let's finish their picture. This is a 60. Okay, so let's say we had their problem. They had started with a 7 here. Okay, we're doing number 20. They have a 30 and a 60. Okay, well, we know that's similar to another triangle over here with 30, 60, 90. And across from the 30 is my small. Across from 60 is my medium. Across from 90 is my large. Okay, so if I want to figure out what this missing hypotenuse is, I would use a proportion going from left to right. So I would say x is to 2 as 7 is to 1. So it would be cross multiplying, you get x equals 14. So we get a different answer, so that's not right. But they told us that. They had this big x here saying this is not correct. It looks like what they did is they accidentally thought it was proportional to this side that had a square root of 3. So I think when they set up their triangle, they must have had the square root of 3 over here and 2 over here. And this is a pretty natural mistake. I mean, if you're thinking small, medium, and large for sides, across from 30 is my smallest. Across from 60 is my medium. It's easy to slip up and think that 2 is smaller than 3. Because 2 is smaller than 3, but 2 and the square root of 3 have a different relationship than 2 and 3. Okay, so it looks like they swapped these sides, which is a really common mistake. So I wanted to highlight this one. Okay, so let's do a more challenging problem now. Okay, let's look at something that's now a composite drawing, like number 17. This doesn't even have a single triangle in it, so what the heck? Okay, well, first off, if we're dealing with right triangles, let's see if we can create a right triangle in this picture. Now, I see some right angles over here, so I guess we could add something, you know, like this, but that's an unknown length, so we don't want to do that. Okay, so let's see maybe about we come in this direction. That'd be a length 5. That might be useful, but then we're not so sure about the other angles in this left triangle with T and U. We would have 45 and who knows what and who knows what. So that's not going to help us enough. So instead, if we add in a perpendicular here, like an altitude or height of this triangle on the left, we get this right triangle, which is 45, 45, 90, and a rectangle. And what do we know about a rectangle? We know the opposite sides are congruent. So now we've got a right triangle down here that's 45, 45, 90. And what are the sides of this? Well, the hypotenuse is t, the height is 4, and this bottom here, this total Okay, this total is u, and we just took away 3. So what's left over on the left is u minus 3. Okay. Let's look at this. What can we figure out here? Okay, well, this and this are congruent, so we don't even need to do any sort of, fancy math there. We just know this bottom part. It's an isosceles right triangle. It's 4. So u is 4 plus 3. U is a total of 7. Okay, but t, I don't want to do some shortcut like that. Let's remember our 45, 45, 90 triangle here. 45, 45, 90, 1, 1, root 2. So I'm going to set up a proportion going from this top triangle to the bottom. It is t is to root 2 as 4 is to 1. So we get t times 1 equals 4 root 2. And so that one I use a proportion, although you could have absolutely realized there was a 4 to 1 scale here. So you could have just multiplied this by 4 if you noticed that. All right, so what we're going to do now is we're going to switch over to IXL and get some practice on there. All right, so here we are in IXL. We're practicing Q4 in geometry. So I've got a 30, 60, 90 triangle, and I want to find the value of u. So I'm going to set up a 30, 60, 90 triangle oriented the same way. So it looks like this. And we've got our 30, 60, 90. I'm going to say across from my 30 is my smallest. Across from my 60 is my medium. Across from my 90 degree is my largest. And then I'm going to set up a proportion. And I'm going to go in this direction here. So u is to 1 as, and then we get 9 root 3 is to root 3. Now notice we don't even need to cross multiply here because u divided by 1 is just u equals 9 root 3 divided by root 3. Those cancel and we get 9. Okay, so I'm going to go in here and I'm going to write 9. Perfect. Oh, perfect. So it brings us to a 45, 45, 90 triangle, our other one. So let's draw one oriented the same direction. So here's 45, 45, 90. Here's 1, 1, root 2. So going from here to here, we get j is to 1 as 8 root 2 is to root 2. Again, j over 1 is just j is equal to these cancel 8. Okay, we got a 30, 60, 90 here. So let's go 30, 60, 90. We got a across from our small, across from our medium, across from our big. So in this direction, we get q is to 2 as, that's a crazy q. Q is to 2 as 1 is to 1. So cross multiplying, we get 1q, or just q, is equal to 1 times 2. Perfect. We'll just do a few more here. Just really want to extend this practice, so if you're not getting it, I can show you as many practice problems as you need. Feel free to get back to your assignment at any time here. So we have a 30-degree angle, a 60-degree angle. I always orient it the same way as the original drawing. Across from my small, across from my medium, across from my long. Proportion going in this direction. Okay, so we've got f is to root 3 as 3 is to 1. Cross multiplying 1f equals 3 root 3. All right, I feel like that's enough practice. We will stop there. I hope you enjoyed this video.